All right, this is a short overview of DHCP, Dynamic Host Configuration Protocol. So what does it do? Well, up until this point, we've probably only ever configured our IP addresses manually during the system installation. So there was a question that asked, what IP address do you want to use? What's your subnet masks? What's your name servers? Stuff like that. Now, that has its place, that has its purpose, but a lot of times that can be very tedious. If you're managing a large number of hosts or clients, it's not feasible sometimes to go sit down at each one of those clients and manually configure those IP addresses. So DHCP is a protocol that will automatically go out and assign the IP addresses for us, so that we don't have to do it manually. So here's the components of our dynamic host configuration protocol. First, we have a server, and the server will receive those clients' requests and will respond to them. The client is bundled with the operating system of a client computer or other IP-capable device, and which sends configuration requests to the server. Think of, obviously your operating system, Windows, Linux, OS X, those all have DHCP clients built in. But think of these smaller devices that we have nowadays, like a Fire TV or a Chromecast or a smartphone or anything else that connects to the internet. Most of the time, you don't go in and manually configure those IP addresses. Most of the time, you're waiting for those IP addresses to be assigned to you by the router. So the router itself provides the server functionality, but your client, whether it's an Internet of Things device or some other smartphone or something like that, has a client package built into it that knows how to request a DHCP address. This third component is optional, but we'll throw it in there, a relay agent. This is used in case the DHCP request needs to travel to a different local area network. Well, by saying, so that being said, then we can also identify that DHCP is designed to only work across a single network, or within a single network, I should say. And we'll talk about how that works. Basically, it's a set of broadcast messages that are sent out, and broadcast messages typically are not sent from one network to another network. So this relay agent allows a DHCP request to travel to a different local area network, so that we can have a single DHCP server set up to serve many LANs, and we actually have that set up in our configuration. So it is very practical and useful. So let's see if I can open this in a new tab. There we go. So we're looking at the DHCP. This is actually what the protocol does. We're talking about the DHCP protocol and kind of the procedure and order of operations that happens here. So the first thing that happens is the client. The client sends out a DHCP discover message to identify DHCP servers. And so we plug into the network, or we connect to a Wi-Fi network or a wired network, whatever it is. The device immediately sends out a broadcast message. And if you remember from networking class, this broadcast message is in an Ethernet frame, and it's just sent out to the broadcast address of FF, 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 whatever. Keep filling up with Fs until you have the full MAC address there. And so this signifies to every client on the network or every service listening on the network that it should listen to this package, that it should accept this packet and process it. So we send out this discover message. It goes to everyone that's listening on the network. Now, the DHCP server should receive that message that's sent to FFFFFFFFF, and it should then say, oh, you are requesting a DHCP But this is a DHCP packet. You're asking for an address. And I'll go ahead and give you an offer. So the DHCP server responds with an available IP address and options. So hey, here's an IP address you can have, and here's some various options you might want to be aware of, like subnet mask, DNS servers, some other stuff like that, search domain, stuff like that. So then it's sent back to the client. The client then says, well, all right, yeah, I like that address. I'll go ahead and request that from you. And the DHCP server then will send back a message, an acknowledgement message that acknowledges the request and completes the initiation cycle. And at that point, the DHCP client then binds that IP address to the network interface card, and we are ready to go for networking. So we kind of already talked about this. The initial discover is sent to the broadcast address of the network. By the way, back here, we want to memorize this acronym, DORA, like Dora the Explorer. Anyway, discover, offer, request, acknowledge. But that initial discover was sent to the broadcast address of the network. And I was talking about it in terms of Ethernet layer, but in terms of IP layer, this is the broadcast address it was sent to, the IP packet. Meaning that any and all DHCP servers will respond. So if there was more than one DHCP server, they will all respond. In the offer, so the offer message, if we come back here, so this discover message is sent broadcast. The offer is sent unicast. How can it be sent unicast? Well, because we actually have that guy's MAC address. We know this guy's MAC address because it was attached to the outgoing discover message. Doesn't have an IP address, but it's okay. We'll actually send back an offer as a unicast address. The R part of it, or the request, that's also still sent to FFFFF, because we don't have an actually network address yet. So, and then finally the ACK, or the acknowledgement, that is sent back as a unicast address again, because the DHCP server has full network functionality and he still knows his MAC address. So by the time it's done, then we obviously, once we've bound that NIC, then we can send everything unicast or whatever we want to do. Okay, a couple other notes. DHCP on the server runs on port 67. On the client, port 68. And in the case of multiple offers, the client will accept the first offer it receives. Some details here. The client responds with another broadcast that will accept that proffered IP. Okay, we already said that. That was an acknowledgement. I'll go ahead and, back here, the request, I'll go ahead and take that. Thank you. That was a broadcast. The server stores that IP and responds with an ACK. Other DHCP servers will also receive that, the first message here. Oops, this first message. And they will know that they aren't the ones that are serving this DHCP server, and so they won't participate anymore. But the client binds the IP to the network interface card after the acknowledgement. The acknowledgement contains other stuff as well, at least how long you can have this address. And that's pretty important because we don't want to just give them an address forever. So we usually have, DHCP has a lease time, which says how long this address is good for. And the server expects clients to respond at 50% of the lease time. If that fails, it will wait till 87.5% of the lease time. Now, it's kind of vague, but let's just say that our lease time is 10 minutes. We'll wait and hopefully the client will respond to us at the 5-minute mark, or 50%. But if he doesn't, we'll still let him have it until 87.5% of the lease time. So whatever that is, 8 minutes and whatever, do the math, 40 seconds or something. If we haven't received another renewal request in that time, well, then the DHCP lease generation process starts over again with the DHCP client broadcasting a DHCP discover message. Every time a client device restarts within the lease period, it contacts the configured default gateway. If a gateway does not respond, the client considers itself to be on a new subnet and enters the discovery phase. So think about that. You have a cell phone or something. You take it from home to the school. At home, you're contacting your own local router to get a DHCP address. But then you leave, you drive up to the school. Let's say your lease is 10 minutes, and whatever. You initially negotiate that lease, and after a few minutes, you decide to go up to campus. You're on a different network. Obviously, it would need to. It would try to contact a configure default gateway, or it would see that, in that particular case, it would see that your wireless access point is no longer available. It would try to connect to the other wireless access point, and then would have to renegotiate a DHCP lease there and a different network address. So clients will redo the DORA when they detect they're on a new network. We could look at a Wireshark example. I'll save that in a future video. But let's talk about types of leases that we have. The first case is the one that let's just look at it. I was explaining this, but there's actually two different ways of doing a lease. First of all, hosts are not guaranteed any particular address within a range. So you bring your laptop to campus, you are not guaranteed that you're always going to have the same address. You'll have a certain address within a predefined range, but it's not always the same address. So the use case there is just what I said. Laptops, hosts that change frequently. Now I'm going to jump down to fixed for just a second. A fixed address lease given by a DHCP server does not change. The administrator configures the address on the DHCP server. Hosts will then check out the lease from the DHCP server, as we've explained. But in this case, a use case for this would facilitate managing a large number of clients without having to edit configuration files. So in our lab environment, for example, we have 100 PCs or operating systems that need an address. Those machines are always in our network and they don't move. So a fixed lease might be appropriate for them. And the way a fixed lease works is basically on the server will receive that MAC address from the client. And it will look up that MAC address in a table, and it will say, oh, well, I have that MAC address, and that table is a MAC address to an IP address mapping. And if it finds that mapping, it'll say, oh, okay, well, you always want it to be this IP address, so that's what I'll do. And we will do this during the semester. The final type of address, and I don't know if I wouldn't call it a lease, because this one actually doesn't even use DHCP, but a static address. So I should have categorized this as types of addresses. A static address is what we've been doing all along. It's where during the system installation, it asks for an IP address. We manually put the address in there. Maybe we're editing Etsy network interfaces. Maybe we are going to Windows settings if we're on Microsoft Windows, and we're setting manually or statically the address there. That address will never change unless you go back and edit that same file again. So the use case for that, when would we want to do that? When we're using a server or anything that we cannot tolerate failure if it can't contact DHCP. Consider the scenario of a name server. Let's say my DHCP server fails and my name server tries to renegotiate a lease, can't find it. Oops, well, we can't get an address for my name server, so in effect, all of my name server resolution stuff will not work. So static addressing is what we've been doing, but dynamic and fixed DHCP addresses are the two that we're going to explore. How does DHCP and DNS relate to one another? Well, DNS expects known IP addresses. Meaning, let me back up on that. When we're using DNS, like to go to a particular website, cit.dixie.edu, that DNS usually does not, can't handle a changing IP address by default. Now there are some ways around that, but traditionally DNS expects a known IP address. And DHCP, though, can cause an IP address to change. How do we make sure that DNS records are the ones that DHCP has served out? Well, first of all, I would usually, if I'm putting something in DNS, I would probably just make it a static address on the server or a fixed address so that they don't change. But in the case that I want a dynamic address on my server, there is such a thing as DNS dynamic updating, where DHCP can go modify your DNS entries. Once again, the server or the DHCP daemon will go in and modify your DNS entries. Special configuration has to make that happen, but it is doable. DHCP is used with IPv6, but it works a little differently, and we may get to that. So in our environment, before we set up DHCP, one of the first assignment that we were supposed to do is to restructure perhaps our addressing scheme so that all of our addresses were contiguous. So I put my servers in this contiguous address block, 34 through 39, and then maybe I'll create a couple clients towards the end that are at the end of my IP address space. Anyway, we'll talk more about that, but that's essentially our goal is to make client 1 and client 2, instead of a fixed address here, we want to make them dynamic.